This will be for the con assignment, graphs of exponential functions. All right, it says use the interactive graph below to sketch a graph of this function here. And we're going to have to plot 2 points and then the asymptote. Okay, notice as I move this, it changes the graph. So let's do the 2 points first. Those will be easiest. Now, we know that anything to the power of 0 is just going to equal 1. Okay, like if we did 3 to the power of 0, that's going to equal 1. So I want to try to make this 3 to the power of 0. All right, so I'm going to do my x and y coordinates here. So what would make this 0? Well, of course, 4 minus 4 would make this 0. Okay, so at x equals 4, we would have 3 to the power of 4 minus 4 plus 1. Okay, and that's 3 to the 0 plus 1. But 3 to the 0, let me write this out, 3 to the 0 plus 1. Okay, we know 3 to the 0 is just 1, and 1 plus 1 equals 2. So at x equals 4, y equals 2. All right, so we have 1 point, and let's do one other point because we have to do 2 of them. All right, another easy one. 3 to the 0 is 1, and we know that 3 to the first power would give us 3. Okay, so what value of x would make the exponent equal to 1? Well, that would just be 3 because 4 minus 3 is 1. Okay, so at x equals 3, we have 3 to the power of 4 minus 3 plus 1. Okay, 3 to the power of 4 minus 3, that's 3 to the first power, plus 1. 3 plus 1 is just 4. So there's your 2 points. All right, so let's get those out of the way. I'm going to go to x equals 4, y equals 2. All right, so let's see. If I go to x equals 4, y equals 2, I'm right there. And x equals 3, y equals 4. All right, at x equals 3, y equals 4. Okay, so I have 2 points. And finally, we have to imagine what happens as x increases or decreases. So this here, if the exponent gets bigger and bigger, this will be 3 to the negative something. Okay, you have 3 to the negative 4, negative 5, and it keeps going and going. But we know that is the same as 1 over 3 to the 4th, 1 over 3 to the 5th. So as x increases, this actually gets smaller and smaller. All right, it can never be negative, however. So the smallest this could be is just 0. Okay, in which case you would get y equals 0 plus 1, which equals 1. In fact, it'll never even reach 1. All right, but if x gets more and more negative, this exponent just gets bigger and bigger, and this whole thing approaches infinity as x gets more and more negative. So the smallest that y could be is 1. So what you want to do is on the graph, bring this up to 1. Okay, this way, as you can see, this graph keeps going, and it kind of approaches 1, but I'm not sure if it ever reaches it. But that's really all you have to do here. Okay, we got 2 points and the asymptote. All right, here they give us the graph of y equals 3 to the x, and they want us to say the graph of this function here. All right, so this is a transformation, but I just think it's too complicated to do all of those transformations, so I'm going to just get some points. Okay, so let's see. Let's just get some simple points. We know that 3 to the 0 is just 1. Okay, so if x were 5, we would have 5 minus 5. So let's evaluate it at x equals 5. We would have negative 2 times 3 to the power of 5 minus 5, which is the same as negative 2 times 3 to the 0. All right, 3 to the 0 is just 1. Negative 2 times 1 is negative 2. So that's one of the points. All right, and let's see. We know that 3 to the first power is just 3. So let's try that. All right, if we put in a 4 here, we'd have 5 minus 4, and the exponent would be 1. So let's see. That's going to be negative 2 times 3 to the power of 5 minus 4. Okay, 5 minus 4 is 1. 3 to the 1 is just 3. So negative 2 times 3 is just 6. All right, so we have those. And that might be enough as it is, but let's just think about one more thing. All right, let's say x is increasing. This is going to be 5 minus a bigger and bigger number. So the exponent is negative. That makes the fraction smaller and smaller. So eventually, this is going to come close to 0, and negative 2 times 0 would give us 0. So as x increases, y goes to 0. And you probably don't even have to do this much, but just in case, as x decreases, this is going to be minus a negative. This exponent gets bigger and bigger, which makes the whole thing right here, as the exponent gets greater and greater, this whole thing gets greater, but it's times negative 2, so it's actually decreasing. All right, so we'll check those 2 points first, and then we'll check the other stuff. At 5, it's going to be negative 2, so it's not A. At 5, it's negative 2. That's good. At 4, it's supposed to be positive 6. It's not B. It's not C. And let me see. At 5, it's negative 2. And at 4, let's try and see what 4 is supposed to be again. Okay, I see what I did. If this is 4, the exponent is 5 minus 4. That's 3 to the first, which is 3 times negative 2. So this is supposed to be negative 6. All right, let's check again. At 5, it's negative 2. All right, it's not A. At 5, it's negative 2. And then at 4, it's negative 6. It's not B. It's not C. It's definitely D. All right, at 5, it's negative 2. And at 4, it's at negative 6. So there you go. This stuff wasn't necessary, but it is good to know. Okay, like we said, when x increases, it goes to 0, and we can see it's on the x-axis, which is y equals 0. As x decreases, it goes down, so we can see that as well. All right, last one. We're going to sketch this here. So we'll do the x and y coordinates once again. All right, so the simplest one here would be 2 to the 0. We know that 2 to the 0 is just 1. What would make the exponent 0? Well, that's x equals 1. Okay, and that would give us negative 1 times 2 to the 0 plus 6. Negative 2 to the 0 is 1 times negative 1 is negative 1 plus 6 is 5. All right, so that's 1 point. And the other easy point would be 2 to the first power. That would give us 2. All right. So what would make this to the first power? Well, if x were 0, it would be 1 minus 0. All right. So if x is 0, we have negative 1 times 2 to the 1 minus 0. So that's 2 to the 1 plus 6. Negative 1 times 2 is negative 2. Plus 6 is 4. All right, so we have those 2 points. And then finally, we want to find the lowest or highest point that it can be, like the asymptote. As x gets more and more negative, it's minus a negative, so this becomes larger and larger, okay? But if the exponent gets more and more negative, then this whole thing becomes closer to 0. All right, so as x increases, the exponent gets more and more, increases in the negative direction. And this approaches 0. Negative 1 times 0 is 0, and 0 plus 6 is 6. So as the graph goes this way, the highest it should be is 6. All right, so let's do that. All right, at x equals 1, it's 5. So go to x equals 1 and then bring it to 5. At x equals 0, y is 4. Okay, so at x is 0, y equals 4. And we said the highest the graph could be is 6. So just left click, hold it down. Darn it. Left click on the green line, hold it down, and you can drag it up and down. Okay, let's double check. 0, 4 is a point. 1, 5 is a point. That's right here. X equals 1, y equals 5. And the highest it can be is 6. So that's it. All right, so that's it.